Hi, Assalamualaikum everyone. We are from Group 3 and my name is Aida Zahira Azhar and I will start presenting this experiment number 4, which is minor losses in pipe. So the abstract for this experiment is pressure measurement bench, which is the apparatus we used to find the average flow rate of water in each pipe section. The purpose of the findings are to determine the loss coefficient and minor head in pipe components or fittings for different water flow rates, pipe diameters and pipe bends. The resulting data are meant to provide the effects of different water flow rates, pipe diameters and pipe bends on the value of loss coefficient of the pipes. The factors contributing to errors or inaccuracy in experimental data are also briefly discussed. So the objective for this experiment is to determine the loss coefficient KL value and minor head loss HLM in pipe components or fittings for different water flow rates, pipe diameters and pipe bends. So the introduction to this experiment, minor losses HLM are determined experimentally as flow through valves and fittings is very complex and expressed in terms of the loss coefficient KL. Minor losses happen when fluid in a typical piping system passes through various fittings, bends, or abrupt changes, the expansion and the constriction in addition to the straight sections of piping, which interrupt the smooth flow of the fluid and cause additional losses because of the flow separation and mixing they induce. The value of KL is strongly dependent on the geometry of the component considered as well as the fluid properties, includes the Reynolds number, which can be expressed as KL equals to phi geometry RE. Reynolds number. Eddy's waste mechanical energy occurs downstream of the valve is due to induced swirling turbulent eddies that are produced in the valve and continue downstream, which then ultimately dissipated into heat, while the flow in the downstream section of pipe eventually returns to fully developed conditions. The purpose of this experiment is to determine the loss coefficient KL and minor head loss HLM in pipe components or fittings for different water flow rates, pipe diameters, and pipe bends. Finally, we have to discuss the effects of different water flow rates, pipe diameters, and pipe bends on the value of loss coefficient KL. I will pass to the next presenter. Thank you.
Hello everyone, I'm going to be explaining the theory. So, the flow in piping system at different flow rates may be required to pass through a variety of fitting bends and abrupt changes in area. Additional heat losses called as minor heat losses are encountered primarily as a result of flow separation. So by simplifying the Bernoulli equation between 2 points for horizontal pipe, the pressure loss and the total heat loss could be determined using the following equations. And the value of loss coefficient is strongly dependent on the geometry of the component considered, as well as the fluid properties, and the mathematical function of them can be expressed using that following equation. So loss coefficient for sudden expansion or enlargement and contraction in circular pipes are shown in figure 2. Note that losses for a sudden expansion are based on the speed of flowing medium at region 1, whereas for a sudden contraction are based on the speed of medium at region 2. So this is figure 2 showing the loss coefficients for flows through sudden area changes such as sudden contraction or sudden expansion. The value of loss coefficient for the fluid flows through a sudden expansion and contraction can be obtained by considering the continuity from equation 7 and the momentum from equation 8 and energy equations between point 1 and point 2 from equation 1 for the control of volume shown in figure 2. The resulting three governing equations are as written below here. And the value of minor head loss and loss coefficient for flows involving pipe components such as elbows, pipe bands, and pipe branches could be determined using equation 3 to equation 5. An example of typical values of loss coefficient for pipe components are shown in figure 3. This is the figure.
Assalamualaikum and hello everyone. So my name is Shahrul Reza. So today I will be presenting our group apparatus and methodology for this experiment. So the apparatus we use in this experiment is the pressure measurement test bench. So inside the pressure measurement test bench, there's five main equipment, which are the manometer, the inlet valve, the pipe expansion, T-junction, and also the pipe band. So as for the methodology, the first method is the direction of the water inflow and outflow is set for the tested pipe section. So the second one, the inlet valve of the tested pipe section is fully open by turning it into anti-clockwise direction. The third point, the main switch and the pump is turned on. Next, the manometer tube is connected from inlet flowing pressure H1 and outlet flowing pressure H2 of the tested pipe section to the two tube manometer. Next, for the first reading, the value of H1 and H2 at two tube manometer is recorded. So the sixth point, the time taken to collect 3 liters volume of water at the tank is recorded for the actual flow rate Q actual. Point number 7, so the opening of the outlet valve is reduced for the second reading for the experiment. Next, the value of H1 and H2 at the two tube manometer is recorded. The method number 9, once again, the time taken to collect 3 liters volume of water at the tank is recorded for the actual flow rate Q actual. Next, the opening of the outlet valve is reduced and steps for manometer reading and data for actual water flow rate for another 3 different value of QX is recorded. Next, the procedure is repeated for another tested pipe. There's three tested pipe, which are first, sudden enlargement pipe, second, sudden contraction pipe, next, different branches type, which are consist of Y type and T type, and next, the pipe elbow, which consists of 90-degree angle, 90-degree bend, and 45-degree angle. And lastly, all the data is recorded on the table. That's all. Thank you.
Selamat sejahtera. My name is Scott Ryan, and for this experiment, I will present the results and the discussion for my group. So based on the result, this is the result that we get from our lecture that was given. So as you can see that yes, the time, the value of Q actual, which is we calculated ourselves, which is 1 over time, and then H1, H2, and then also delta H, which is the difference between H1 and H2. And this is for the sudden contraction. Also, this is the result for angle 90 pipe, bend 90-degree pipe, angle 45-degree pipe, and then for the Y-type pipe and also the T-type pipe. Next is the discussion, which is the first question of discussion is to calculate the value of loss coefficient and the HLM of the pipe. So first, the Q average of the southern enlargement pipe is 0.000389 meter cube per second, and then the diameter is 0.02 meter, and the first diameter of the orifice is 0.02, and then the second one is 0.032 meter, and then the T is 0.0015 meter and T2 is 0.0018 meters. So first we need to find the D1, which is D1 of the diameter of the pipe minus 2T1 respectively. So it's 0.02 minus 2 multiply with 0.015 and we will get 0.017 meter. We also do the same for the diameter of the second one, which we will get 0.0284 meter. And then we will find the area, which is using the formula pi over 4 d square, the diameter. So we just substitute the value and we will get 2.27 times 10 power of negative 4 meters squared. Same with the second area, which we will get 6.33 times 10 power of negative 4 meters squared. And then we can calculate the value of loss coefficient by using this formula, which is 1 minus area 1 over area 2 square. So we will get the loss coefficient value of 0.4114. And then we also need to calculate the Q average, the velocity, which is using the formula of 4 over pi multiply the Q average over pi d squared, which we will get 1.714 meter per second. And then lastly, we will, using all the values that we already calculated, we can find the value of HLM, which is KL multiplied with V squared over 2G. So we will get 0.0616 meter. So for the sudden contraction, the value of Q average is pretty much the same. Same with the diameter, only the position of the diameter is exchanged. Just like the first equation, we need to find the diameter and then also the area, and then for the KL and then the velocity and also the HLM, which has the same value as southern enlargement. So next, I will explain about the pipe of angle 90 degree. So the Q average is 0.00036 meter cube per second. The diameter is 0.0017 meter, and the loss coefficient value, the loss coefficient value KL is 1.5, which is given from the manual, the diagram pipe manual. So from this information, we can just find the velocity, which using the same previous formula, and we can get 1.586 meter cube meter per second. And then lastly, find the HLM using the same formula, just substitute the value, and we will get 0.1923 meters. So for the bend 90 and angle 45 degree pipe, the equation is pretty much the same. Only the difference is the value of KL, which is for bend 90 degree is 0.7, and then for angle 45 degrees it's 0.4, which will get the value of HLM of bend 90 degree is 0.0897 meter, and 0.0513 meter for angle 45 degrees. So next is about the Y-type pipe. So the Q average is 0.000312 meter cube per second. Diameter is also the same, 0.0017 meter, and the loss coefficient value is 2. And then using the same equation, a formula, we can find the value of velocity of 1.375 meter per second, and also the HLM, which is 0.1927. Same with T-type also. Only the value of Q average of T-type is different, which is 0.00382 meter cube per second. So the velocity is 1.683 meter per second, and the HLM is 0.2887 meter per second. So the second question for the discussion is discuss the effects of different water flow rates, pipe diameters, and pipe bends on the value of loss coefficient KL. So when the flow rates of water increases, the friction losses in pipe also increases. Thus, the value of loss coefficient increases. And then if the diameter of the pipe increases, less energy will be lost due to friction because there is more space for the water to flow. So as a result, the loss coefficient will be much lesser. And then next is the pipe bend. So the longer the bend of the pipe, the lower the value of loss coefficient. And after that is the third question, which is briefly discuss factors distributing to errors or inaccuracy in experimental data and propose recommendation to improve the results. So for the first error, which is parallax error, which is the error when reading the manometer. So the way to improve this is to make sure that your eye level is directly perpendicular to the manometer so that it is more accurate, or perpendicular to the meniscus level of the manometer. Yes. And then next is error in reading or calculation due to external factors such as the environmental factors. Environmental factors has so many variables. So in order to avoid that, the experiment must be done in an ideal condition so that any external factors will not affect the outcome of the experiment. The next error is to make sure that the instrument that are used during the experiment does not have any zero error. Zero error is when the instrument has not inaccurate value of the scale. So if we use a instrument that has zero error, we need to immediately replace it, or we can just take note the value of zero error, and then we take it into account when we do the calculations in the results. The next is presence of air bubble must be avoided. So the presence of air bubble will make the reading the manometer will be inaccurate. So if there is air bubble present in the tube, we must remove it out of the tube by like dripping the water out of the tube and then refilling it again with water. So that is all for my part. Thank you very much.
Next, for conclusion, with the data collected from this experiment, we can calculate the minor head loss and loss coefficient. The value of loss coefficient differs as the size of pipe changes. For example, sudden contraction or sudden enlargement. From this experiment, we learned that when the flow rate of water increases, the value of loss coefficient also increases. Due to several differences in variables and calculation, the resulting values vary with when the formula is used. From this experiment, we can conclude that minor head loss varies with the different size and angle of the pipe.